good. Why? How can you tell the 2's in the wrong place? It's kind of a weird question, but you want all of your Q's in this case together on one side and all the numbers on the other side. The Q's are all together. They're doing what they're supposed to do. It's the numbers that are, what the hell's wrong with you numbers? Since the Q's have this side, I need to move the numbers on the other side.
Yeah.
So yeah, you would add 2.
Okay.
And then of course, one more step and reduce it. You guys, so if you did, this is not quite done, but you guys can finish it. If you do something like this, right? And I'm not just picking on the person that asked this, because a lot of people do this kind of thing. And then sort of things are just floating. These are floating, and you divide, and I don't know what process you're using that says it's okay to divide there, because I know I can divide both sides of an equation. I can't divide things just hanging out.
Especially can't divide it.
And so a couple things wrong. I can't really do this. Plus, what does this other side become?
0.
Yeah, so you got to bring that with you, because that's still there. So that's kind of like overloading one side and trying to do everything on one side. That's not going to work. You could come up with the right answer, but for the wrong reasons. So you got to be careful. Yeah, I like it. Yes?
You also couldn't divide, you can't divide a plus or a minus equation if you're adding or subtracting it.
You got to make sure what you do actually cancels what you want it to cancel. Because I don't know if that's what you're saying, but I still get too many people doing something like this. They'll do plus 2, yay, and then they'll do plus 14. All right, that does not make sense. I know you've got to connect more to what's there, what it means. I know in your head you're like, negative 14 and 14 cancel, Jeff. What do you want from me? But that's not negative 14. That's negative 14 times Q. So addition cannot cancel multiplication.
Yeah, that's what I was saying.
Yeah. So that won't ever work. That's why I keep saying it's the operation that you're actually trying to cancel. That's the only time something can cancel is if 2 different operations are working. Yes? Anything else from homework stuff or in general stuff? Yes?
Can you do 285?
Maybe. What's it say?
10, bracket 5, parentheses n plus 1, parentheses, plus 4, parentheses n minus 1.
Oh.
And then bracket equals 11 bracket
Holy crap.
7, parentheses 5 plus n, parentheses minus, parentheses 25, minus 3n, parentheses, then bracket.
Yeah.
Like that.
Yeah, not very long. It didn't really take a whole board. All right, so I want you to realize both sides of this equation are kind of like simplification problems, right? So that's the first thing you do is you look at each side as its own problem.
Right.
So
I just get to, after the parentheses, I do combine like terms inside the bracket.
oh wait, let's get there.
Okay.
So what's the first thing I do on this side?
Distribute the 5.
So the first thing you do is inside here, right? Because brackets are just another form of parenthesis. Love you guys. So definitely, so the last thing we're going to worry about is that 10. I'm going to do inside here. And the first thing I do inside here is, like you said, distribute. Yeah.
Okay.
So I get
5n plus 5 plus 4n minus 4.
equals, who cares? I'm not doing that side yet. Yeah, and then now what can you do? The reason you distributed is so that everything's free so that you can go ahead and put them together.
If I don't combine like terms and I just distribute the 10 to all of it and combine later, it doesn't matter?
Doesn't matter.
Okay.
Yeah. It's just, I would rather put this stuff together and have less to
Right.
multiply by 10, yeah.
Right. Okay.
Does that first step make sense?
Yeah.
You're just simplifying, so you do inside the parentheses first, you distribute in here first. Now I can get my like terms together. 5 in and 4 in. 5 minus 4. And then I can distribute. And now you do exactly what you just did, you do it on the other side. And then if you get both sides kind of done, then you get to a standard place where you choose which way to go with your ends and which way to go with your numbers, yeah. Oh, I love this room. I really do.
Thank you.
Yeah. Oh boy, this is really on a short leash.
Can I help you?
No, it's connected to the wall, so it's
There's another connection.
it's only, no, you don't understand.
Oh.
It is very connected to the
Oh.
wall, yes.
Big
He's like, you don't understand.
Yeah, it's not just a cord, it's a bundle of cords.
Thank you.
Okay, that's better. Is that one all right? I mean, that one is really on the heavy end of level of equation solving. I agree. You guys all right? But like any math problem, one of the biggest mistakes people make is for some reason you guys, I think some of you guys think you're supposed to know where things are going to end up. When I'm doing a problem, I have no idea where it's going to, I have no idea where it's going to end up. But PEMDAS is kind of always there, telling me what to try first. And then some basic ideas like distribution is there for me. So distribution hopefully is relatively easy. Combining like terms needs to be relatively easy, right? So don't look at the whole, in fact, did I give a shit about that side at first? No, I forgot about it. But I think some students think you're supposed to have the whole thing in mind somehow. That's impossible. So people that do well at math sometimes are the people that naturally break things into parts, which is a good life lesson, to be honest. You guys doing all right? Some of you guys look, I'm sorry. Well, I'm a math teacher. I'm used to depressing people. But I'm sorry. I'm adding to shit for you. But that's as far as I'll go. You guys, the other side, you do exactly the same idea. You distribute the 7. You distribute the negative, right? I think that's what you told me it was. Is that
Do
right?
you distribute the negative, or is it just, you could just have it as a minus, right?
It is a minus,
So you
but
just distribute the 7 to the 5.
sure. All right, maybe we should do this first few steps.
Yeah.
11, 7 times 5 is
35.
35, 7 times n.
7 and
What's in front of the parentheses?
a negative 1.
Negative 1. Negative times 25 is?
Negative 25.
Negative times negative 3n is? And now you can put your like terms together.
If you don't distribute the negative,
Then you're wrong.
okay.
I really want, so if I
Because it's the
say,
same thing, like it's I guess
no,
it's
if
not.
I say 7 minus 5,
Yeah.
that's 2, right? So if I say 7 minus 5 plus 2, what am I taking away from 7? Not just 5, I'm taking 5 and 2. Now, of course, I would do 5 plus 2 is 7, but just to show you, you could rewrite this as 7 minus 5 minus 2. Because what am I taking away from 7? 5 and 2. So that's what the distribution does. It makes sure that both of those things are being taken away. And if you still don't like that, we know there's a negative 1 out front. And what do I do with any number sitting in front? Distribute it. I like it. Is it still a little too warm in here?
Yeah.
I don't know. This thing likes to go too far with settings. Let's see what happens. Let's see what happens. All right. Anybody have maybe a smaller question to look at, where I'll just make one up? Because this is kind of like at the extreme end. I really want you to understand this. I don't mean because this is hard. I mean because there's a lot of pieces to it. That doesn't make it hard, it just makes it long. Those are very different. So people kind of give up on a problem that's got a lot of parts to it. Well, each part is relatively simple. You just have to know how to train yourself to only care about one thing at a time. The whole universe is 5 times this. Okay, now we can move on to the next universe.
So instead of trying to do the entire equation, you should
Yeah, for some reason I think students, you think you're supposed to be able to keep the whole equation in your head. Oh God, no. No. Right? In fact, like how would you do, real quick, how would you do 2 times 5 times 8? What's 2 times 5 times 8? 80, right?
Yep.
Is that right? There is nobody, I don't care how good at math you are, there is no one that can do all 3 multiplications at the same time. We all have to do 2 times 5 and then times 8. Do you understand what I'm saying? But then, a problem like this, so see how I only care about 2 times 5 at first? And then I worry about the 8? I mean, that's math. I pick a problem, that's what I know order operation says in here first. I do this, that is the only thing I care about. And if I gave you this problem on a test and said simplify, would you not go, yeah? Or, maybe not so creepy, but some version of thank you. Yes?
How did you get 9n plus 1? I think I missed that.
What's 5n plus 4n?
Oh, you combined like
Yeah, now it's the whole purpose of distribution is to free things up so you can do like terms. Yes. That's why we distribute somewhere first in an equation. Okay, all right. Now you look less depressed and more like you want to hurt me, but I'm not sure. I'm not going to stop trying to read your emotions. Anybody, another question, or I can make one up. Let's see. Which one was that one? Oh, 285.
Yeah, I might need you to finish that because I feel like I'm getting the same answer, and in the book it's wrong.
Oh, I'm not saying this is the case, but there's typos in the solutions. Of course
It was
there's.
like
Why?
4 times. I get.
No, it's okay. I'm not saying that's what's happening here. You could be making a mistake. I am saying the solutions were created by humans.
Okay.
I don't give a shit how good at math you are. Humans will make mistakes somewhere. How many answers are in that book? A lot. So what's the chances there's at least a few typos? Very high.
I think I did something wrong.
Huh?
I think I did something wrong.
All right. So you never know. It's one of those two things. If you're getting every one of them wrong, it's probably not all typos. So, but if you're getting like one wrong, you feel pretty good about it, it might be a typo in the solutions. All right. Let me make a problem up. Let's catch ourselves up to where we left off. I don't know if you guys realize, we have been spending a decent amount of time on solving equations. Part of it relies on you doing your homework, asking questions, getting help. Solving equations is the bread and butter of algebra, period. If you cannot solve equations, you cannot do anything. Word problems are hard, right? Do you agree with me? Have you ever done a word problem? Do you like them? Okay, I understand. I do. I appreciate that answer. It's awesome. But the easy step should be, once you have the equation set up, that should be the easy step. So we need to be able to solve equations relatively well before we get into doing other things. So we build one that's got just a little bit less going on than the last one. So what's the very first step?
Distribute the 4 and the -1.
Say again, sir?
Distribute the 4 and the
Yes.
-1.
Let's see what that does. So almost always in an equation, one of the very first steps will include distribution. And again, why? Because otherwise I can't get my x's together because they're stuck in these stupid prisons, right? So I'm going to break them out first. So So what do I get there? I like it. Well, there you go. And then what happens here? Good, -5. Good, plus 2x. So really pick up on what's important here. I'm being really nice to myself. I'm changing just a couple things. Every other thing that's not changing is staying right where it is and coming down. Right? I'm not saying you have to do it exactly like I do, but you need something to keep in mind where things are. On what side of the equation are they? Things like that. Now that I've done that, I'm allowed to do what?
Combine like terms.
Yes. So what goes with 4x? And real quick, I still get some people doing this kind of thing. What did that person just do? And why do you think they did it? Is that wrong?
Yeah.
I mean, you can tell from my tone. Even if you thought it was right, you're like, apparently from what you're saying. That is definitely wrong. What they're trying to do is like what you would do to both sides, right? That's when that would make sense. But they're doing all of it to just one side. That's not fair. So what they actually just did is they subtracted 4x from this side and did nothing to that side. That is not fair. Get out of here. This is 4x plus 2x. They're in the same side already. You just put them together. Right? There's no need to move anything. They're together already. So what is 4x plus 2x?
6x.
And what is -12 minus 5? I like it. Right, so those go together, equals is still here, 11 is still there. Kick ass. And then
You subtract, you add 17.
add 17 because it is subtraction, so I can cancel it.
6x equals 28.
28.
Divide.
6x
You divide by
Divide 6.
6. And then I can reduce this, right?
Yeah. Divide.
Because I'm going to divide top model by 2, right? To reduce it. When in doubt, don't put in your calculator. Just reduce it. Don't give me no decimal. Don't give me no hard time about my
Also,
grammar.
so if there's a remainder, you just put it under.
I'm glad you said that. We're way past big ass R. Do you guys know what big ass R is?
Yeah.
If you did 3 into 14, I do not want to see any R. No, we're way past that shit,
You
right?
just put it in into a.
How would you write this officially? 4 and 2/3, yeah. Or you just keep going if you want to make a decimal, right? Yeah. You guys know what 2/3 is?
Yeah.
1/3 is point. So 2/3 is point. Yeah, so maybe. Okay, enough of that. So don't try to get too far ahead of yourself. Don't just, if you see parentheses, that more than likely means distribute. That's kind of one of the first things you look for is, do I distribute somewhere? Because that frees things up so you get like terms together. Okay, I like it. Let's see, what about, so I can use more of the board. Here, why don't you just go over there? Okay, all right. Let's do, yeah. There's a couple different ways to do this one. Unfortunately, some of us kind of like just don't even write it. Hopefully, hope I don't notice, because you're like fractions. Nah, pass, Jeff. Come on. So if you want to, you can kill the fractions, right?
Yep.
The trade-off is you will make the numbers bigger. But do you notice something? Are all your x's together?
No.
Yeah.
Yes, yes.
Yes, they're all right there. Right? Do you guys see that? All right. So if you want to make it a rule where you just always kill the fractions, you totally can. So let's do this two ways. Let's kill the fractions first. How do I kill the fractions? No, careful. It's more than one fraction. There's more than one reciprocal up here, isn't there? So what I have to do first before I can kill the fractions, I have to make all the
Well,
bottoms the same.
by making.
How many bottoms do I have? Good, 3. What's the LCD?
5.
15,
Oh, yeah, 15.
right?
Yeah.
So he doesn't have to change. He needs a who? And he needs 15.
Yeah.
Yes? So then I get 15 times 5 is 75. Let me stop for a second. You got to be able to do that. You got to be able to make an LCD. So that's all we just did. Everybody got the same denominator because now, how do I kill it? Everything is being divided by 15. So how can I undo that? Multiply everybody by 15. Die, die, die. Totally die. So what's left alive? 75x minus 6 equals 11. Hey, that looks nice, right? You almost don't care about the 75 because he's just going to be the last step and you'll be done. Do you guys see that? So I did make the numbers larger, like I told you. That's the trade-off. Okay, you can kill fractions, but you're going to have to, something's going to have to happen. And then, of course, yeah, say again. Yes, add 6 to both sides to cancel it, die. Okay. Divide 75. So I get x equals 17/75. Is that actually? No, almost. Not quite. It won't reduce. How you guys doing? Are you guys all right? Now, let me show you a different way to do this one. So anytime you see fractions in an equation, it is an option that you can kill them. If you make all the bottoms the same, you can multiply both sides of the equation and kill the bottoms, which is killing the fractions. If there's no denominators, there's no fractions. Yes?
You said you can't reduce, or you're not going to?
You can't.
You can.
If it was 85 on the bottom, yeah, what's 75 divided by 17? Yeah. Is 17 is prime, is that cool? If 17 went into 75, that's the only way I could reduce this. But 17 does not go into 75. 17 goes into 85. Is that all right? So let's try this problem out a different way in case you want to see. The reason I might not want to kill the fractions is because this is almost done. The x's are all together already, right? So how do I get this by itself? Add the 2/5. Now, of course, before I can do this, I need LCD. Multiply this by 3. What's 11 plus 6? Yeah. Right? And then I got one more step. There's a fraction in there. So instead of dividing by 5, I can multiply by 1/5. That's when multiplying by the reciprocal becomes useful, is if there's a fraction somewhere in my equation, let me multiply by the reciprocal so it lines up fraction to fraction. And then you get x. X, Jeff? Sure, what ain't? 17 over, yeah. Thank God the same question, same answer we got there. Okay. Either way works. So I don't know if you guys have noticed this, but I live off of questions. So I am fine if somebody has a suggestion for like a type of equation to look at, or if you still don't understand why I'm doing something, I could do another example that involves that. We need to get equations down, or else we're not going to make it very far through this class.
When I was looking at the equation, I didn't understand it at first, but what I understood is as soon as you get the, was it the 2 times 3, you add it to.
Oh yeah, well, I mean 2/3, 2/5. To make it the same LCD, I multiply by 3. So I didn't write this, but this is 6/15, right?
Yeah.
So this is 11/15 plus 6/15 is 17/15. Yeah.
I actually did.
I like it. And just remind you guys, I see in your faces there are questions. If you have a question, so do at least 8 other people. They just don't want to speak. So you could be their hero, if just for one day.
I did.
Yes.
For 295 and 300, all the way through 310, it says, in the following exercise, classify each equation as conditional equation,
Oh yeah.
identity,
All right.
or contradiction.
So watch this. We did equations where the answer was like 5 = 5. You guys remember what the answer was?
Yeah. Oh,
All real numbers.
so we have to plug in what was
The
fine.
official name, no, just remember if you solve an equation, you get 5 = 5, the answer is all real numbers.
Right.
Because it's always true. The official title for that kind of equation is an identity. Do I care so much about the name? No, I care about the answer. So they are called identities. And then the ones that, like if I do it and I get 5 = 4,
Contradicting.
contradiction, there's no solution, it contradicts itself.
And then conditional would be A equals.
Conditional is a normal one.
Okay.
Because, so when I solve this and I get this answer, what does that mean? What does it mean if I get this answer? What exactly does that mean?
We plug in 17.
This will only work on the condition that x is equal to this.
Right.
You with me? So what is if I take hostages, what am I going to tell the police? I'm going to tell them the conditions of my releasing the hostages. You got to meet these conditions. So the only way that this will work, it's going to release the hostages, is on the condition of this being true. So that's why that's officially called conditional. Again, I personally don't care so much if you know the names. I want you to be able to tell me the answers. So don't circle 5 = 5. That doesn't tell me shit. The way to interpret it is, oh, anything would work. Because it's always true. Yes?
Did you say there's another name for no solution? Like all real numbers is.
Oh yeah, this is a contradiction. Is that what you mean? Yeah.
Yes, thank
That's
you.
the official title for it. I don't really care too much about some official titles. What I care about with equations is what's the answer.
You also don't like oil.
Well, yeah. Anything that makes it sound like it's harder than it really is, I don't like. Yes?
Can we not put true and then not equal sign?
Wait, what? What?
Like 5 = 5, just put a solution.
How do you mean?
Or equal, true.
But that doesn't tell me what the answers are.
So you have to write all real numbers.
Do you understand? How do you know when you're done with an equation when you can tell me what the answers are?
Right.
So if you say true, that doesn't tell me what the answers are. All real numbers, okay, there's the answers. No solution, okay, there's the answer.
Oh,
There's
you
no
cannot
solution.
do a slash on the equal. not.
Oh, sure. But it's because 5 does not equal 4. So let's here. All right, let's solve this equation. What's the first thing I do? Distribute. I like it. What do you guys get? 2x plus 2. Let me get my x's together. How do I kill these x's?
Negative 2x.
Now, some people will just erase that and assume you've made a mistake. You let what's going to happen happen. It's okay if the x's go away. What do I end up with? So the correct way to fully interpret what I just got is this equation is true if this statement is true.
It's not.
Okay.
And it's not.
So is this statement ever true?
No.
No. Therefore, is the equation ever true? No. So no matter what the hell you make x, you can't save this equation's ass.
So
Right?
it's-
So don't put a not equal to, because then that's a true statement. So because this is not a true statement, that's why there's no solution. Does that make sense? Now, some of you guys also have used this symbol before in the wrong place, but now is the appropriate place to use this symbol. If you know what that symbol is, it's called the empty set. So if I said, give me the set of all the answers, and you're like, here's an empty set. I'm like, oh, that's a weird way to say there's no answer. Okay, that's fine. So that is an acceptable symbol. Unless you've never seen it before, not really comfortable about it, then just don't use it. I like it.
How we know?
Say again? Sorry?
How we know no solution?
Okay.
Now we get 2 equal minus 7.
In order for this equation, so watch, the one I just had up here. Here, wait. So if I solve this equation, what do I get? How do I solve this one? Yeah, -1, and I get x equals 6. So what's the correct way to interpret this? This equation is true when this statement is true. Let me say it again. The correct way to interpret the result of a solution of an equation is the equation will be true if the thing I found is true. Right?
Yes.
That's why to check it, I make the thing I found true, I put it in, and then I see if the equation is then true. You guys see what I'm saying? How do I check it? I make this true, I put a 6 in there, and then I see if it's true. That's how I check it. So, you interpret it exactly the same way here. This equation can only be true if this statement is true.
It's not.
What the hell's up with freaking manners? This shit. Would you ever walk into the middle? Tell you what, I'm still, there are people that come every third day, so I thought for a minute he might be one of the students. I'm sorry. I'm feeling like Rancy today. You don't just come in the middle of the class, do you? Would you? Would you do that?
I would
I
say,
think that
excuse me.
was rude.
Yes, okay, I'll stop. I'm
What
sorry.
would we say then? Would we be
Huh?
like, hey, can I get my stuff?
Yeah, you can say, hey, man. I'm like, no, you'll wait till I'm done. Because, I mean, that's the way it works. Holy shit. It's your
He's
fault
the
to leave us.
only one who lives in this world. You can't.
I know. I forgot. I got the memo. All right, coming back to this. I'm sorry. Coming back to this, you interpret it the same way. This equation can only be true if this statement is true. Is this statement ever true? Right here. No. Therefore, there's no solution. There's nothing that will make this work because this can never be true. I like it. That's how you know. So if I get a true statement, like 5 equals 5 at the end, or, then it's an identity. All real numbers. Doesn't matter what x is. Right? If I get a false statement, then it's no solution. If I get a statement like x equals 6, then it does work only when that's true. Any other number I put in here, it won't work for. That's why it's called conditional. On the condition that it's this one thing, it'll work. I like it. Yes?
If I didn't subtract the 2x to completely eliminate the 2x, but instead I subtracted the regular 2 and put that on the other side,
Sure.
is that an okay way of doing it as well?
Well, then you're not done yet, right? 'Cause
Well, yeah, but I mean,
Yeah. So you could end up with 0 equals -9, right? So if you do this equation, and you do this first, right? Is that what you're
Yeah.
saying?
yes,
You still have to eventually get your x's together.
correct.
So then you will get 0 equals negative 9. You didn't get a different answer than me because that's still not true.
Yeah, I just didn't know if
Yeah.
it had to end up in the x equals -6 as no solution versus it doesn't really, I understand it doesn't matter what the overall answer is as long as it's not.
Yeah, if there is no solution, you'll end up with something that's never true.
Okay, I just didn't know if that was the way you had to do it, where you did the two.
No,
bits.
no, no, no.
Okay.
As long as you get your numbers on one side, letters on the other,
Okay.
you're fine. Yeah, okay. All right, maybe. I love you guys. All right, so let's kind of sneak into the next thing here because we need to. We've been focusing so much on equalities. Let's talk about inequalities. Right? So something like one of the most basic things. I already gave you a way to remember the symbols and what they mean. The one that looks like an L that fell over is less than. Right? If you like the alligator thing, it's great. Whatever the hell keeps it straight in your head. So how would you read that?
Or is not, I'm sorry, is less than or equal to.
Beautiful.
negative.
So 4x is less than or equal to negative 8.
Less equal.
Less than or equal to, right? So for example, on the side, less than or equal to. So if I put a 7 here, give me a number that can go there and it's true.
7.
7, I love it, because 7 is less than or equal to 7. And then of course anything like 7.2, or if you like whole numbers, 8, right? It's got to start at 7 and go up from there. All right. Now, how do I solve this? You solve it exactly the same way we solve equations, except for one little thing.